What's up everyone? Today's a double header. I'm kicking off a brand new AI project for OBS Studio and then diving deep into a challenging LeetCode graph problem. Stick around to see how it all unfolds. This is day 49 of coding every day until I hit 1K subs. Today, I started a new project and also tackled a LeetCode problem. Let's get into it. So first up, the new project. I've been wanting to do this for a while. I've initialized a new repository for a tool I'm calling. It's still very early days, just the initial setup for now. Here's the initial README. The goal is to create a Python project that uses artificial intelligence to generate real-time dynamic segmentation masks. The idea is you could point it at, say, your DJ controller or keyboard, and it would create a mask for just that object. This mask could then be used with OBS Studio's image mask or blend filter, which could be super useful for streamers or anyone creating video content. I'm pretty excited to see where this goes. Alright, after getting the new project initiated, I switched gears to tackle a LeetCode problem. This is problem 1857, largest color value in a directed graph. Quick spoiler warning if you're planning to solve this one yourself. The problem asks us to find a path in a given directed graph, where nodes are colored, such that the count of the most frequently occurring color along that path is maximized. We need to return this maximum count. A key condition is that if the graph contains a cycle, we should return -1. My approach for this problem uses a combination of topological sort, specifically Kahn's algorithm, and dynamic programming. This is a solid strategy for problems on directed acyclic graphs. First, I build an adjacency list to represent the graph and calculate the in-degree for every node. Then, I initialize a DP table. Let's call it DP_counts. DP_counts for a specific node, and a specific color will store the maximum count of that color found on any path ending at that node. I also set up a queue and add all nodes that have an initial in-degree of 0. These are the starting points for our paths in the topological sort. Next, I process nodes from the queue in topological order. For each node dequeued, I increment its own colors count in its DP table entry. This updated count immediately becomes a candidate for our overall max_color_value_found. Then, for each neighbor of the current node, I propagate the color counts. The neighbor's DP entry for each color is updated to be the maximum of its current value, and the value from the current node. The neighbor's in-degree is decremented, and if it becomes 0, the neighbor is added to the queue. After the loop, if the number of nodes processed is less than the total, a cycle exists, so we return -1. Otherwise, we return the max_color_value_found. This has a time complexity of order v plus e, where v is vertices and e is edges, and space complexity of order v times c for the DP table, c being constant 26, plus v plus e for the graph representation. And that's a wrap for day 49. A new project started and a tricky graph problem solved. If you enjoyed this, please hit that like button, subscribe if you haven't already, and let me know in the comments if you have any cool ideas for the obs-ai-dynamic-mask project, or if you've tackled this LeetCode problem differently. You can also support the channel over at buymeaboba.com, link is in the description. Thanks for watching, and I'll see you tomorrow.